Hello, my name is Marcio Viana. I'm the creator of Voima. And in this video, we'll see how to simulate a pump failure scenario in a rising main. As is often the case, I began by organizing all the relevant data in a spreadsheet that you can see here. In this spreadsheet, we have data such as the piping elevations, the hydraulic grade line, the pump chart curves, more specifically its power curve and its pump head curve, and also other data such as pipe diameters, pipe material, pump inertia, and so on. Okay, so step 1 is taking the spreadsheet over to Voima. From the My Project section, we go over to the Upload button, choose File, and then select our spreadsheet. Notice that it shows up here in the bottom left. Now let's create a new project and give it a name. For example, Rising Main 300 meters. Shortly after, we are going to be taken to the flow sheet, where we're going to be doing most of our work. Okay, so step 1 is to import the data that we've just uploaded from our spreadsheet here onto the diagram. To do that, right-click anywhere empty on your diagram and head over to Diagram, Spreadsheets, and then XLSX, Load Spreadsheet. We position our block, click on it, and notice that there's a spreadsheet drop-down. We click on it and select the spreadsheet that we've just uploaded, which in my case is called risingmain.slsx. Okay, now we have a reference to the spreadsheet. What we need to do now is extract the values from its cells. And the way that we're going to do that is right-clicking on the diagram, going to Diagram, Spreadsheets, and then Load Cell Range. We connect the two blocks, and then we fill in the tab where our cells are at, which in my case is called Rising Main, and then the cell range. If we scroll down, we'll see that the values have been successfully imported. Those, by the way, were the distances along the pipeline, and those are in meters, so we need to tell Voima what the units are. Here, we're going to select meters because these are the units of our project. But if you needed to use imperial units, such as feet, then of course it's perfectly fine. Voima has first-class support for those as well. Notice that I'm also giving a name to that block. I'm calling it distances. This has no effect on the calculation itself, but it helps you keep organized. Now to save time, I am hitting Ctrl-C, Ctrl-V to copy our distance block, and I'm going to import the remaining data from our pipeline profile, namely the hydraulic grade line and the elevations, both of which are in meters. It is good practice to plot the values that we've just imported just to make sure everything is alright. To do that, we right-click on the diagram, go to Charts and Plotting, and then Chart from Series. This will enable us to plot a graph. So we select the distances as our x values, the elevations as our y values, and now we fill in labels for the x and the y axes, and we give the curve a name. By clicking on View Chart, we notice that the elevations plot perfectly matches what we had in the spreadsheet. Now let's add another curve to this graph, namely the hydraulic grade line. As before, we right-click over the diagram in an empty area and go to Charts and Plotting, Add Curve to Chart. We feed the chart that we just built to the input of the new block and connect the distances and the HGL that we just imported and connect them to the block. We also give the new curve a new label. And again, if we click on the block and click on View Chart, we'll see a plot of the pipeline elevations and now with the hydraulic grade line. I'm also going to give this new chart a name. Okay, so now I'm gonna copy paste this whole section and bring in the values corresponding to the pump curves, namely pump head and power versus flow rate. I'm also being careful about the units here. I am using metric because this is how the data was given to me. But if you needed to use imperial, it would have been just the same. Now again, I'm adding blocks to plot the graphs just to make sure everything's alright. And we see that the pump head curve is looking good. Let's do the same for the power curve. And again, it's looking good. Great. Now that we have our input data in place, we can start calculating the water hammer. The first thing we'll do is right-click on the diagram to open the pop-up menu, head over to water hammer, and then create scenario. We position this block, which is very simple, and the only thing we're going to specify here at this point is the simulation time. I'm going to leave it at its default value for now of 60 seconds. Now let's create our boundary conditions. Right-click, water hammer, create reservoir. So this is our downstream reservoir. We should give it a name. This name has to be unique. Let's call it, for example, R1. And let's input its water level, which for our problem was equal to 55 meters. The other boundary condition is the pump. But before we define it, we need to include the curves that we imported from the spreadsheet into the water hammer scenario. So here we'll take create curve. We connect the blocks and give it a unique name. I'm going to call it head curve. Now we need to give it the x and y values. In the head curve, the x's are the flows and the y's are the pump heads. We already have these values, but they are pretty far apart from this block. To help you keep your diagram organized, instead of dragging a connector all the way there from the left, we can create a link block and make a reference to it. This helps your diagram become consistent, easy to use, and organized. This is going to help your diagram remain consistent, easy to read, and easy to use. Okay, now let's do exactly the same for the power curve. Notice that, again, I'm giving it a unique name. And to keep things organized, I'm also giving the block itself a name. Okay, now let's create the pump. We connect it to the blocks, give it a unique name, and notice that here I am referencing the curves that we just created using their unique names. Now I'm going to fill in the rest of the data. Okay, so now the last piece we're missing is the pipeline itself. So we add a pipeline stretch and start filling in the data. Notice that it also requires a unique name, and we need to specify both the upstream and the downstream boundary conditions. Our upstream boundary condition was the pump P1 that we just created, and the downstream condition was the reservoir R1. Okay, now it's all ready for us to simulate. So in order to do that, right-click, water hammer, simulate method of characteristics. We add this block anywhere, connect it to our scenario, and notice that the results already came through. Now, there are several ways you might want to view your results as. One of the most common ones is through an animation showing how the hydraulic grade line moves as time passes. If we click here on View Animation, we'll see just that. Now, animations are really nice for you to get a sense of how the dynamics of your system works. But if you're writing a report, probably what you need are the envelopes showing how high and how low the hydraulic grade line went. And here in Voima, you can do that quite easily using the Get Envelopes and Plot Envelope blocks. And here it is. This is probably the most common type of graph that you'll see in water transient studies. You can also take these envelopes and further process them. For example, you might want to take your maxima, subtract them from your profile elevations, and get the gauge pressure. We can then take its maximum value, and here we see that it's roughly equal to 100 meters. Okay, now we may want to take all these results and display them in an easier to read format, and maybe even export them as docx files so that you can later embed it in your reports. Let's click here on Notebook. In the Notebook view, you can create reports. Here you add what we call cells, which may contain variables, arbitrary text that you can write, graphs, and even animations. Once you're happy with your notebook, you can click here on Save Notebook as docx. This will enable you to download a copy of your notebook and then, in your machine, further edit it using your favorite editor. And that's it for today. In the following videos, we'll learn how to add water hammer protection devices. See you later.